Welcome to the world of equation solving. Today, we'll explore what equations are and understand the fundamental goal of solving them. An equation is a mathematical statement that shows the equality of two expressions. Think of it as a balance that must remain equal on both sides. Just like a balance scale, an equation must have equal weight on both sides. The equal sign acts as the fulcrum maintaining this balance. Here we have the equation 2x plus 3 equals 11. The variable x is what we need to find. It's our unknown value. Solving an equation means finding the value of the unknown variable that makes the equation true. Our primary goal when solving equations is to isolate the variable on one side of the equation. This means getting the variable by itself. When we successfully solve our equation, we get x equals 4. The variable is now isolated and we have found its value. Throughout this series, we'll learn to solve different types of equations, from simple one-step problems to more complex multi-step challenges. We'll start with one-step equations like x plus 5 equals 12, then progress to two-step equations, and finally tackle multi-step equations with parentheses and multiple operations. Each step builds on the previous one, making you a confident equation solver. By the end of this series, you'll have all the tools you need to tackle any equation with confidence. To solve equations effectively, we must understand the fundamental principles of equality. These principles are the foundation that allow us to manipulate equations while maintaining their truth. Think of an equation as a balance scale. Both sides must have equal weight to maintain balance. When we have x plus 3 equals 7, both sides are in perfect equilibrium. The first fundamental principle is the addition and subtraction property of equality. This states that adding or subtracting the same number to both sides of an equation maintains the equality. Let's see this in action. We start with x plus 3 equals 7. To isolate x, we need to subtract 3 from both sides. We subtract 3 from the left side and subtract 3 from the right side. This keeps the equation balanced. The result is x equals 4. The equality is preserved because we performed the same operation on both sides. The second fundamental principle is the multiplication and division property of equality. This states that multiplying or dividing both sides by the same non-zero number maintains the equality. Here we have 3x equals 12. To isolate x, we need to divide both sides by 3. We divide the left side by 3 and divide the right side by 3. Again, this maintains the balance of the equation. The result is x equals 4. Once again, the equality is preserved through our systematic approach. The key to applying these principles effectively is understanding inverse operations. We use opposite operations to undo what has been done to the variable. Addition and subtraction are inverse operations. They undo each other. Similarly, multiplication and division are inverse operations that cancel each other out. These fundamental principles of equality form the foundation for solving all types of equations. By understanding that we can perform the same operation on both sides and using inverse operations strategically, we can isolate any variable and find its value. One-step equations are the foundation of algebra. These are equations that require only one mathematical operation to isolate the variable and find its value. A one-step equation needs just one mathematical operation to isolate the variable. There are 4 main types based on the operation involved. The 4 types are addition equations, subtraction equations, multiplication equations, and division equations. Each type uses a different inverse operation to solve. Let's solve our first example. X plus 5 equals 10. To isolate x, we need to eliminate the 5 that's being added to x. Since 5 is being added to x, we use the inverse operation, subtraction. We subtract 5 from both sides to maintain equality. Simplifying both sides, x plus 5 minus 5 equals x, and 10 minus 5 equals 5. Therefore, x equals 5. Always check your solution by substituting it back into the original equation. 5 plus 5 equals 10, which is correct. Now let's solve a multiplication equation. 2x equals 16. Here, x is being multiplied by 2. Since x is multiplied by 2, we use the inverse operation, division. We divide both sides by 2. Simplifying, 2x divided by 2 equals x, and 16 divided by 2 equals 8. Therefore, x equals 8. Checking our solution, 2 times 8 equals 16, which confirms our answer is correct. The key to solving one-step equations is using inverse operations. Addition and subtraction are inverses, as are multiplication and division. This principle allows us to isolate the variable in just one step. Remember to always check your solution by substituting it back into the original equation. This ensures your answer is correct and helps build confidence in your problem-solving skills. Two-step equations are algebraic equations that require exactly 2 operations to isolate the variable and find its value. These equations typically involve both addition or subtraction and multiplication or division. Let's solve this equation, 3x plus 2 equals 14. This is a perfect example of a two-step equation because we need to undo both addition and multiplication to isolate x. Step 1. We need to eliminate the constant term first. Since we have plus 2, we subtract 2 from both sides of the equation to maintain equality. Step 2. Now we need to isolate x by eliminating the coefficient 3. Since x is multiplied by 3, we divide both sides by 3. Two-step equations appear frequently in real-world situations. For example, imagine you're shopping and find a shirt that costs $25 after a $5 discount. If you want to find the original price, you can set up the equation original price minus 5 equals 25. We can write this as x minus 5 equals 25, where x represents the original price. To solve this two-step equation, we first add 5 to both sides. Remember the key strategy for two-step equations. Always undo addition and subtraction first, then handle multiplication and division. This systematic approach will help you solve any two-step equation efficiently. Multi-step equations are more complex than one- or two-step equations. They require us to perform several operations in the correct order to isolate the variable. Let's solve this multi-step equation step by step. We start with 2 times the quantity x plus 3 minus 4 equals 8. Step 1. We need to apply the distributive property. We multiply 2 by each term inside the parentheses. 2 times x gives us 2x, and 2 times 3 gives us 6. So now we have 2x plus 6 minus 4 equals 8. Step 2. Now we combine like terms. We have 6 minus 4, which are both constant terms. 6 minus 4 equals 2, so our equation becomes 2x plus 2 equals 8. Step 3. To isolate the variable term, we subtract 2 from both sides of the equation. 2 plus 2 minus 2 equals 2x, and 8 minus 2 equals 6, so we have 2x equals 6. Finally, we divide both sides by 2 to isolate x. Our final answer is x equals 3. Multi-step equations require us to follow a systematic process. First, distribute, then combine like terms, use inverse operations, and finally isolate the variable. This methodical approach ensures we solve even complex equations correctly. When solving equations, sometimes we encounter equations that have variables on both sides of the equal sign. These require a special approach to isolate the variable. These equations have the general form where variables appear on both the left and right sides of the equal sign. The key strategy is to collect all variable terms on one side and all constant terms on the other side. Let's solve this equation step by step. We have 3x minus 8 equals x plus 6. Step 1. We need to eliminate the x term from the right side. We subtract x from both sides of the equation. After subtracting x from both sides, we get 2x minus 8 equals 6. Step 2. Now we add 8 to both sides to isolate the variable term. Adding 8 to both sides gives us 2x equals 14. Finally, we divide both sides by 2 to solve for x. Our final answer is x equals 7. Let's review the key steps for solving equations with variables on both sides. First, move all variable terms to one side. Second, move all constant terms to the other side. Third, solve for the variable using inverse operations. Here's another example to reinforce the concept. Subtracting 2x from both sides gives us 3x plus 3 equals negative 9. Then subtracting 3 from both sides gives us 3x equals negative 12. Finally, dividing by 3 gives us x equals negative 4. Remember, the key to solving equations with variables on both sides is to systematically move all variable terms to one side and all constants to the other side. When solving equations that contain fractions or decimals, we can make our work much easier by clearing them first. This means eliminating the fractions to work with whole numbers instead. First, we identify all the denominators in our equation. Here we have denominators of 2 and 4.
Next, we find the least common denominator. The LCD of 2 and 4 is 4, since 4 is the smallest number that both 2 and 4 divide into evenly. Now we multiply every single term in the equation by our LCD, which is 4. This includes the term on the right side of the equal sign. Now we simplify each term. 4 times 1/2 equals 2, 4 times 1/4 equals 1, and 4 times 1 equals 4. Our equation becomes much simpler. Now we solve our simplified equation. First, subtract 1 from both sides to get 2x equals 3. Then divide both sides by 2 to get x equals 3/2. By clearing fractions first, we transformed a complex equation with fractions into a simple linear equation that was much easier to solve. This technique works with any equation containing fractions or decimals. After solving an equation, the most important step is to verify that your solution is correct. We also need to understand special cases where equations behave differently than expected. Always check your solution by substituting it back into the original equation. This ensures your answer makes the equation true and catches any calculation errors. Now, let's check our solution x equals 4 by substituting it back into the original equation. We replace x with 4 and verify both sides are equal. Now, let's explore special cases. Sometimes equations don't have exactly one solution. They might have no solution at all, or infinitely many solutions. First, let's look at equations with no solution. These occur when we get a false statement, like 0 equals 5. This means no value of x can make the equation true. The second special case is infinitely many solutions. This happens when we get a true statement like 0 equals 0. This means every value of x makes the equation true. Understanding these concepts is crucial for advanced mathematics. Checking solutions prevents errors, while recognizing special cases helps you understand when equations behave unexpectedly in science and engineering applications. Check the description for free practice worksheets and answer keys. Download, print, and follow along with today's problems.